Hello and welcome to my channel. In this video I will show you how to use the object-oriented programming in MATLAB to work efficiently with a large sets of data. In this video you will learn how to create a very useful class, how to preprocess data, how to load them from the txt file and many more. If you are interested in such a content, don't forget to subscribe to my channel and I will help you further. Okay, so let's start. Our data are in the directory which is here. Okay, here is a data directory and we have four txt files which contains each 36 records with 8760 columns each. Those are quite large sets of data, which are the hourly average values of meteorological parameters. Okay, so how to work with such data? It can be a bit problematic if you don't know how to manage the workspace. Workspace can be messy and that's a problem. This problem we will solve using object-oriented programming. Okay. So let me start. Clear. CLC. Okay, and I will create two MATLAB files. First will be a main file when I load the data, and the second will be the class definition for preprocess our data and many more. Okay, so let's start with the main file. The command okay, so for now I need to load my data which are in the data directory. Okay, so I need to search in this directory, which is very easy. Data. Okay, the function is dir directory, and then I need to place here a path to the directory because my directory is directly here, so just the name of the directory. Data. Okay. So let's have a look what it's return, this function. Okay. So I have got a table of structure in here, and let's have a look into this structure. So we've got four fields which contains the names of our files. Okay, so those are here. The names of the files are the names of the cities in Poland in which the data were collected. Okay, so those are the names. But we also have those two fields which are for now uninterested for us, and we just need to delete them. Okay, so data, access data, convert to end. Okay, so I just delete those unnecessary fields, and now I've got clear the structure. So now my idea is to go through this table of structures and create an object of my class which I will define for each set of data. And in this object, I will have methods to preprocess data and to work with them. Okay, so now let's start work with our class definition. Okay, so I start with a comment, which is just a good habit. For now, it's not needed for me. Okay. Class def, sorry, class def is a keyword, the name of the class, my class, or for example data class. Okay, and now we will use three different properties types. We will use a public property, private property, just to refresh your memory about what is the private property, and most important, the dependent property, which are great for pre-processing purposes. Okay, so let's get started. Okay, properties. I will not define an access because in default the access is public, which is my goal now. Okay, and some fields. For me it will be location, wind speed, oh, I'm sorry, I'm typing mistake, temperature, and the solar irradiance. Okay, just for purposes of the example. Okay, next, the private property. So I forgot typing. Okay, but now I would like to have the private property, so I'm using set access to private. Okay, and now for example I will define the value of the air density for a normal conditions. Just to remind you that the private property is really good because no one can accidentally change the value of it. If, for example, you work with some team, 1.225 kilogram per cubic meter. Okay, not important. And the most important now are the dependent properties. Okay, so I can set access dependent just by typing dependent like this. Okay, it's just other way, not like set access equal to private. I could also just type private or dependent. Okay, and what is important, that those dependent variables will be calculated just after creation my class object. So the idea is that I will create the object of my class for each set of data, and then I can pre-process the data. For example, calculate the standard deviations or the mean values or something like those just during creation the object, and I will have access to those informations in my main code. Okay, so for example, temp std, the standard deviation for temperature, and for example average temperature. Okay, and then we start the public methods block to define the constructor. So methods, and okay, and similar like before, the access is public by default. So I start with the constructor, and then I need to use the keyword this. Is a similar like in a C++ language, for example, this, and then the class name, which is data class. Okay, suppose I type it correctly. this syntax tells us that the constructor will return this particular object of the class data class. This is good to have it in mind. Okay, and now the arguments of our constructor. So for example, temp, which will be a temperature vector, vs, which will be the wind speed vector, location, and solar irradiance data. Okay. There is also a way to construct overloaded constructors, or even dynamically overload the methods in class, but I will present it for you in a separate video to do not make too much mess in this one. Okay, so now in this constructor we only assign the arguments to a proper fields which are here. Okay, so I just call the proper field in this way, this data class dot, and then the name of field, which is here, for example, location. Okay, it will be more convenient. Location, assign log. That's all. So that's all what I want to do in a constructor. Okay, and this is a difference between MATLAB and, for example, Python, because in Python all the computations which I would like to perform during creation my object would be in a constructor, but here in MATLAB those computations which I need to perform to have the value of standard deviation for temperature and the mean value of temperature, I need to perform in a separated functions called getter functions. So this is a difference between MATLAB and, for example, Python or C++. Okay, so now we will create the getter functions to compute those parameters, but have in mind that it will be called just like a constructor, just after constructor. Okay, so function, and now there is a specific syntax for getter function. So the name of the dependent variable, in this case temp std, and now get dot the name of this variable temp std. Okay, and then the argument of the function would be the object of this class, this particular object of this class. So the data class. Okay, in this manner this function have access to the fields of this object, so it can take the temperature vector and calculate the standard deviation for it. Okay, so temp std, and we just use the built-in function, which is std for the temperature vector, which is in a field temperature in this object. So the data class, I call that particular object, I call the temperature field, which is the vector. Okay, and that's all. So we also need another very similar getter function, so I just copy and paste it, and then I need to change this. Okay, notice that now MATLAB tells me that the syntax is improper because I need to change also here. Okay, and then the syntax is okay, change also here, Okay, so now in case of syntax everything is okay. I just need to change the function for mean to calculate the average value. Okay, so that's all about the getters for now. Of course it can be much more complicated if you have more sophisticated needs. This is just for the purpose of the example. Okay, so let's have a look what we can do if we have some much more complicated calculations to perform, and for example those calculations are already created, the function for it is already created, and we want to use it inside of our class. This is a situation I have here, because here I have a procedure which implements the mathematical model of a photovoltaic panel, and the idea is to use this function in here because we will have the possibility to calculate the power generation for this photovoltaic panel for each location which we have data from, and it will be very convenient what you will see in the tests. Okay, so the function is quite complicated, not too much, but it is a mathematical model of PV panel, which if you want, let me know in the comments. I will prepare another videos about it if a decent amount of people will want it. But for now, just use this function in here to see what the advantage is connected with such a usage. Okay, so the point is how to call this function inside of the class method. So I create another public function, okay, which will receive the which will return the power generation for a day, for example. It will be clear for a second. PV power. This is the name of the function, and this function will of course have the access for the all fields of this object. So I need to use the data class. Okay, and now inside this function I just call my function panel PV. Okay, so PG panel PV. Okay, and now the arguments of this function are the solar irradiance vector, temperature vector, and the wind speed vector. Okay, so I need to call fields of my object, so the data class dot, and now solar irradiance, then, and I'm so sorry, I remember that I also need to transpose this vector, which is just because of the structure of code of this function. It needs that the vectors need to be vertical. Unimportant for you now. Okay, and then the temperature vector, so the data class temperature. Okay, also transpose. Okay, and then last argument, which is the wind speed vector, the data class dot wind speed. Okay, I just need to check, do I type everything correctly? I guess I do. Okay, and now, as I said, we would like to compute the daily average values of the generated power to have a better readable plots. So this function returns the average values, hourly average values of the generated power, and if I want to have the daily averages, I just need to perform one simple operations, which is okay. So this line works in that way that here is the generated power, and then the reshape function make from one big vector, which is one row with 8760 values for each hour, make the table which have 24 rows and 365 columns for each day, and then the min function calculate the average value of this for each day. So very simple thing. Okay, and the last one we would like to have, just for presentation purposes, is the plot of the results. So I need to create a domain, line space, okay, so I just create a vector of 365 values for a domain, and then a plot. The title of a plot, which will be, for a better readability, the concatenation of the name of the figure, which will be the PV average power generation in. Okay, and the next argument will be the location. Okay. Okay, so I guess that's all for this class definition. Let's have a look for the tests. But firstly, we need to make our data loading from txt file and our object creation. So I need a for loop to go by this table of structures data. So for k okay, and now I need to have a path to my file to open it. Okay, it is quite simple. So I have the variable path, and then create the path by concatenation the name of the file and the name of the directory. Okay, horsecat data slash, and then the data, which is this particular table, element cave, and the name is a field. It's here, the field name, so it will be, in case of k equal 1, Białystok, in case of k equal 2, Bydgoszcz, no important. Okay, so I have the path, and then I need to open the file. So the fopen function, which I used, returns two variables. The first is the ID of the file opened, and second is the information. Okay, so the argument of the fopen function is just path to the file. Okay, and this is just a really little way to deal with some problems. If we have a problem during, for example, opening the file, then the value of ID will be less than 0. Okay, and if it will be less than 0, that something goes wrong, and we will would like to read the information what was wrong. Okay, so if ID less than 0, then display com. And okay, so this is very simple and unrobust way of dealing with such a situation, and if you want, let me know in the comments and I will make another video about how to properly work with exceptions in MATLAB programming, in objective MATLAB programming. So let me know in the comment. I will perform separated videos about working with exceptions. Okay, this is just an information. Okay, so we need to load data. We use the fscanf function, which will return the array of numerical data, which I called A. Okay, so fscanf, okay, and then the arguments are ID of our file, then the argument which describe what the data are. I mean, those are floating point data which are separated by the space. So in this case I need to use such an code for this information. For different types and different codes, you just need to look at the documentation for fscanf function. There is a table with those codes, and is the best way to do it. Okay, and this is the shape of my matrix with data in txt file. As I said, 46 records for 8760 columns. Okay, and that's all for reading the data. Then I need to close my file, so f close ID. After doing all of this, I just take from my matrix those data which are important for me and construct my object. So firstly the location, and it is in the data file in the name, in the field of name. So data, okay, dot name. Okay, and for example I would like to remove those .txt which is in the end of the name. So from 1 to and -4. Okay, just remove 4 last characters, which is .txt. Okay, now I need to take another vectors, wind speed, which is in 8 column, so it's each row's 8 column. Okay, temperature, which is each row and fifth column, sorry. Okay, and irradiance. Okay, so which is, for example, in 18 columns. I said for example because we have a lot of solar irradiance in those data for a different inclination of the surface and so on and so forth. Not important for now, but very important in case of modeling the photovoltaic systems performance, which I have done some time ago. Okay. And now we create our object. So calling a constructor. Okay, and now I would like to create my data, which is a table of objects, and I will append the objects of data class into this table in this way. Data class, okay, and then the arguments of my constructor, which are here: temperature, wind speed, location, and solar irradiance. Okay, so temperature, wind speed, location, solar irradiance. Okay, and that's all if it comes to creating the object. Okay, so let's go to this file and save it. Okay, I save it. You can see it here. It's saved as data class. Okay, and then I can just start it. Okay, everything was correct, there is no error, and we have this workspace in here. As you can see, as I promised, the workspace is very clean. We don't have too much unnecessary variables in here, too much mess, but what we have is my data table of our objects of data class, and let's have a look how we can easily use it now. My data, for now I just look for my data to show you what it is. It's an array of objects of data class, and each of these objects have the properties of location, wind speed, temperature, solar irradiance, the private properties raw, which we cannot change, which I will show you in a second, and the dependent properties, which is temperature, standard deviation, and the average value of temperature. Okay, so let's see, for example, for a first file. So first object is for Białystok. So there is a location, those are the vectors of our data, the private value, standard deviation for temperature, and average value for temperature. Okay, and if I want to look to another object, okay, so I have Bydgoszcz, and I already have different values for standard deviation for temperature and the mean value for temperature. So I already have those informations. It is very convenient for further work with this data in a main file. Okay, what more? Of course, I can show you that I can call raw just to see it, but I cannot I say I cannot assign anything there because this is a private property. So this is this important thing of do not have a mess and misunderstandings if you work with team. Okay, so it's very nice. So let's have a look about the PV power performance on each of those locations. So I call PV power the class method. Oh, I'm sorry, this is the typing mistake. I should have this in here. Okay, so we have the daily average power generation from a reference PV panel in Bydgoszcz. Okay, and if only we would like to have same information but for example Białystok, we just change it in here. I will also put a semicolon here to do not have those data in my command line, and I have this another plot. So you can see how convenient it can be for work with large sets of data, with modeling such things. If you need to combine usage of quite complicated mathematical model of, for example, PV panel with the really big database, such in here we don't have too big data because we have only 4 files, but in my project it was hundreds of files like that, so it was really important to handle it properly. Of course, if you find it useful, please give a sub, give a thumbs up, and let me know in the comment what you would like to see in the next few videos. In another video I will show you the polymorphism in MATLAB, how to use it properly and how to use it with working with data. Okay, so see you in the next video, and don't forget to subscribe my channel. Thank you.